This is 10-2 on vectors, 10-2 the alpha lesson. Right, you're not accountable for the vocabulary, not accountable for scalars. Okay, that's how you represent a vector. Okay, with the endpoints and that ray above it that's telling you have a vector. And the reason you have this ray here at B is to tell you that it started at A and terminated at B. The length is the absolute value. What does this mean? The two vectors are equal, ready? If you copied this vector and slid it to the left or slid it somewhere else, it would be the same vector. They'd be equal. You write the vectors with these brackets. So that's differentiating them from an ordered pair. You see those brackets, that's telling you it's a vector. How are we going to get the magnitude of it? Pythagorean. All right, so you understand what we're talking about? So you have this vector PQ. So you see the arrow at Q. So it began at P and went to Q. What happens? If we pick this vector up at point P and we slid it 3 to the right down 4, we would get the origin. 3 to the right down 4 for negative 5, 2 would take us to negative 2, negative 2. So the component form of the vector is where how it behaves from the origin, which would be negative 2, negative 2. Which is just telling you what? That you started at P and you went 2 to the left and down 2. What is the length of that? Well, we do a Pythagorean on that, and you would get root 8. And root 8 is the square root of 2 times 2 times 2. And you give each of those 2's their own root sign. And root 2 times root 2 is 2. So you can write root 8 as 2 root 2, but you don't have to. Do not stress about simplifying radicals. You leave the number to the root sign and just move on to the next question. The unit vector has a magnitude of 1. When you add vectors, you add the components. Subtract them, same thing. Well, you can distribute a constant over the vector. Negative 1 would be a constant. Right, so now this is really what is more topical to us. Right, so we have these two vectors, u and v. Well, you understand? That's vector v, so this is vector v. That's u, so that's also u. There's their sum. What happened? Well, that's the shortest distance for when you start here and you ended up where V ended up. Inverse cosine, don't worry about this. Dot products, we're not doing dot products. Just multiplying the components. And again, you're not accountable for this. So how about if we wanted the angle between these two vectors? Well, that's what they did. They did this. You're not going to have to do that. We would do inverse tan for the vectors. Okay? So here's the example that is this is what you're going to use the model do a problem. This is what you have to get your mind around. If you get your mind around this problem right here, you're fine with what you need to know about vectors. Okay? So it's kind of awkward. What's awkward about the picture? Yeah, it looks like it's going west. So it's the plane's. You already have. So the plane is flying 500 miles an hour, and it gets a tailwind. So the tailwind is pushing the plane faster. Does that make sense? It's flying with the wind. But the tailwind's going in the direction of 60 degrees north of east, which means what? Here's east, north of east, there's the 60 degrees. But it's pushing the plane. What's the new direction and new speed? So they say the plane flying in still air is the vector u. Make sense? And now what? Here comes vector v, which is the force of the wind. You all good with that picture? So we want to add these vectors. So what's happening? Well, they're representing these with dotted lines. Why? Well, this is the same vector. This dotted u and the dotted v are the same vector. Where's the plane going? It's going that way. So that's what u is, meaning what? 500 is the velocity, and 0 is the direction. What's v? Well, it's cosine 60 sine 60 on the unit circle, and it's on a magnitude of size change 70. That make sense? See, because really what they should have wrote is this. They should have wrote 500 cosine 0, yes? But the cosine of 0 is 1. And then you would have sine 0, which is 0. So that's, if they wrote that up there, make it easier to see that. So V, ready? 60 degrees, you're here. So what do you got? The cosine is 1/2. 1/2 times 70 is 35. What's the sign? Root 3 over 2. Root 3 over 2 times 70 is 35 root 3. When you add the vectors, 500 plus 35, 0 plus 35 root 3. Because that was the direction of the wind. They said the wind was blowing the plane at 60 degrees north of east. That has to be given to you. Yeah, the 70 was given under what circumstance? It said 70-mile tailwind in that direction. So it was given. The magnitude of the wind was given, yes. So now what? We want the magnitude of the vector. So you're doing that as a Pythagorean. This is a calculator question. And you get this. We want the angle measure. The angle measure would just be this. The inverse tan, right? What's tan? Opposite over adjacent. So we want this, the opposite over the adjacent, because these are the same vectors. Opposite over adjacent would be 35 root 3 over 535. When they're, when you have a right angle there, it'd be 535. This is the 535 to there, beneath that. 500, 535. So now what? So they're saying the new speed is 538 because it's got this tailwind. And the new direction is 6.5 degrees north of east. Okay? So you have access. This is just the last two slides of the Google slides for 10 to day 1. And that's really what's important. And I understand that this is this could be intimidating if you hadn't had physics, but we're just going to have you use this as the model to go to one example. So I'll back this up. And say for you to go to problem 25. Okay, so that slide's up there. And you're going to problem 25. Okay, so the answer is 346.735, 75.734 degrees. Okay, however, here's how we're getting there. Here's U, here's V. So what did I do? I just went to the calculator, meaning you're not going to be held accountable for exact answers with 70 degrees and 130. I mean, you recognize that. So I stored this. 325 cosine 70 degrees in A, 325 sine 70 degrees in B. And I did the same thing for C and D. Okay, the cosine in quadrant 2 is negative. Now, I think we're reminding you the cosine of alpha plus beta and the sine of alpha plus beta. That's why you can't just add these. Yes? So we went over here and said, for the speed, I did the square root of A plus C, the quantity squared, plus B plus D, the quantity squared, to get that component. And then the inverse tan of B plus D divided by A plus C. And that answer came out in radians. So I just multiplied it by 1 in the form of 180 over pi, which will reduce the pi out, and it will express your answer in degrees. Okay? So if you can follow that, even if you didn't have that answer, if you can follow that, that's as far as you need to be able to, or what you have to do, right? So we're going to come back to one more problem, and then tomorrow is your 7th test. So the problem is problem 55 on 10-2.